This is a video from section 8.1. The directions say to find the exact length of the curve, arc length. In number 9, we have y equals 2/3 x to the 3/2, where x is between 0 and 2. Now, to find the arc length, we need the derivative. So y prime is 2/3 times 3/2 x to the 1/2, which is equal to x to the 1/2. So L is the integral from 0 to 2 of the square root of 1 plus x to the 1/2 squared dx. But remember, x to the 1/2 squared is x. And so this is the integral from 0 to 2 of square root of 1 plus x dx. Now, if we integrate, we get 2/3 times 1 plus x to the 3/2, evaluated from 0 to 2. Pull the 2/3 out in front, and I'm going to replace x with 2 to get 3 to the 3/2, and I'm going to replace x with 0 to get 1 to the 3/2, and I'm going to subtract those results. But remember, 3 to the 3/2 is the square root of 3 cubed, right? But we can write this as the square root of 3 squared times 3. And the square root of 3 squared is 3. And so this is equal to 3 square root of 3. And so finally, we get 2/3 times the quantity, 3 square root of 3 minus 1. Remember, 1 to the 3/2 is most certainly 1. And that's how we do problem number 9. So let's take a look at problem number 11. So on problem 11, we have y equals 2/3 times 1 plus x squared to the 3/2. And this is where x is between 0 and 1. Now, dy dx, we need the derivative. Again, we're looking for arc length. This is 2/3 times 3/2 times 1 plus x squared to the 1/2 times 2x. So this is basically chain rule. And if we simplify a little bit, we get 2x times the square root of 1 plus x squared. Now we're ready for arc length. So L is the integral from 0 to 1 of the square root of 1 plus 4x squared times 1 plus x squared dx. Now, let's simplify what's inside the radicand. So this is the integral from 0 to 1 of the square root of 1 plus 4x squared plus 4x to the 4th dx. But do you notice how the radicand is a perfect square? That's not an accident. And so here, L is the integral from 0 to 1 of the square root of 1 plus 2x squared raised to the 2nd dx. Now, most certainly, I can write this as the integral from 0 to 1 of 1 plus 2x squared dx. And so this is x plus 2/3 x cubed from 0 to 1, which is 1 plus 2/3. And so the correct answer here for problem number 11 is 5/3. And that's how we do problem number 11. Let's take a look at problem number 13. They start to get a little bit more difficult as we travel down the page, right? And so here, y equals x cubed over 3 plus 1 over 4x. And here, x is less than or equal to 2 and greater than or equal to 1. Now, just like in the previous two problems, we need the derivative. The derivative here of y with respect to x is 3x squared over 3 minus 1 over 4x squared. Okay? And so this is x squared minus 1 over 4x squared. Now I can do arc length. This is the integral from 1 to 2 of the square root of 1 plus, and then I get x squared minus 1 over 4x squared raised to the second dx. Now, it looks horrible, right? Absolutely. But the key on these is we want to simplify what's inside the radicand and see if we get a perfect square out of that. That's the key to this. And so this is the integral from 1 to 2 of the square root of. Now I'm going to get 1 plus. Now if I take x squared and square it, I get x to the 4th. If I take x squared times negative 1 over 4x squared, I get minus 1/4, but I have to double it. And I'm going to get minus 1/2. And then I'm going to go plus 1 over 16x to the 4th dx. And I want you to pay attention to something, because the last three terms is the square of x squared minus 1 over 4x squared. Okay? Now, look here. 1 minus 1/2 is plus 1/2. And so this is the integral from 1 to 2 of the square root of x to the 4th plus 1/2 plus, right? 1 minus 1/2 is 1/2. And then we get 1 over 16x to the 4th. And we're going to integrate this with respect to x. But I want you to notice the difference between the last three terms here, right? Notice how we have a minus 1/2 in the middle. And then I want you to notice these three terms where it's plus 1/2. And it works out really well. And so this is the integral from 1 to 2 of the square root of x squared plus 1 over 4x squared raised to the second dx. And it works nice, because I could write this as the integral from 1 to 2 of x squared plus 1 over 4x squared with respect to x. Okay? And this is 1/3 x cubed minus 1 over 4x. And this is going to get evaluated from 1 up to 2. And we're going to come over here. If I replace x with 2, I get 8/3 minus 1/8. If I replace x with 1, I get 1/3 minus 1/4. Now, 8/3 minus 1/3 is 7/3. So I get 7/3 minus 1/8. And when you subtract a negative, that just means you add. You get 1/4 there. Now, what's the lowest common denominator between 3, 8, and 4? And I claim that's going to be 24. So notice the LCD is 24. So we get 7/3 minus 1/8 plus 1/4. And so I'm going to put a 24 here. And up top, we get 56 minus 3 over 24 plus 6 over 24. And so L is going to be 59 divided by 24 when we're all done. And that's number 13. And that's a good stopping point for this video. And this is a video on section 8.1. And we did problems 9, 11, and 13. Thank you.